Okay, good. All right.
Ready?
Sure.
Hi, John. Thanks for joining us again.
Hey, Matt, how are you?
Good, good. So a few weeks ago, we discussed climate change, specifically how the pandemic was affecting climate change. So I thought I would do a little bit of a follow-up and ask you some other weather-related questions. As we get into the summer months, I think people are often used to, okay, well, the heat's going up, temperature's going up. But there are also some other weather systems that happen or they start happening in the summer months, such as thunderstorms, tornadoes, and, it's the start of hurricane season. How come this happens now?
How come this happens now? Well, why don't we start with thunderstorms?
Sure.
Just because they're kind of part and parcel of some of these other systems you talk about. It has a lot to do with how much liquid water is available and how much energy there is available. And specifically the contrast between the energy available at the surface and the cooler air conditions aloft above the surface. So let's just talk about liquid water for a second. In the winter months, in a lot of parts of the northern hemisphere, southern hemisphere, a lot of that water is locked up as ice. So it's not available to evaporate quite as easily. But in the summertime, because temperatures are such that things are warmer, you do have greater liquid water availability. So what happens is it allows the water to evaporate, and when water evaporates and it's warm, warm water vapor rises to a point where at the upper levels of the atmosphere, it cools and condenses into clouds. And when that happens, if the condensation is great enough, it forms water droplets. And if those water droplets are heavy enough, they fall out as rain.
Thunderstorms are usually shorter in length, but stronger in force. Why is that?
Well, it has to do with how rapidly that convection condensation process takes place. Okay, so in the summer months here around here in North America, we get our prevailing winds from the southwest, and that's where the warmer temperatures are. So that's the energy source. Well, in addition, you've got all these growing plants, you've got open water on lakes and rivers, so you've got a lot of moisture that's available. Over the course of the day, that water evaporates, temperatures heat up, and so there's that kind of perfect storm of those two things together that causes this convection happen. This is the strong thunderstorms result in this heated air that really wants to rise. And it's also taking the water vapor with it. As this warm parcel is warming the cooler air above it, the cooler air is also interacting with it as well. So it's cooling that parcel. The more energy is available, the higher it goes. So the higher it goes, the clouds happen, you get more intense situations like a thunderstorm that would arise. As quickly as it comes up in the late afternoon, it dissipates as it moves along because we're running out of sunlight at that time. That energy source is starting to go down in the early evening. So that's why the greatest chance of thunderstorms is right at that peak sunlight hour, peak sun time in the late afternoon. That's where the heat is the greatest.
Right. Usually when we experience intense thunderstorms, it is that late afternoon, early evening. Um,
Mm.
and then oftentimes you'll get, now we get all these alerts on our phone. You get a severe thunderstorm warning. Sometimes you may even get a tornado watch or tornado warning, depending on where you live. Do thunderstorms and tornadoes go hand in hand, or in other words, can a tornado form without a thunderstorm, or does a thunderstorm have to happen first before you get to a tornado?
Well, it actually comes down a lot to the definition. Okay, a thunderstorm is only called a thunderstorm if there's lightning that produces thunder. So you could still have a cloud that does everything a thunderstorm does except for thunder and lightning, and it wouldn't technically be called a thunderstorm. But those kinds of things can produce tornadoes as well. By and large, though, in practice, tornadoes and thunderstorms typically go hand in hand.
Got it. And, as I was doing some research before talking to you, I did learn that the US has the most tornadoes out of anywhere in the world. We actually even nickname an area in the central United States called Tornado Alley. Why do more tornadoes form in this area?
It has to do with just the recipe of conditions. And it's not just the source of water and the energy, but it's also the topography, the lay of the land, the landscape. Tornado Alley occurs in the Great Plains. It's an area that is pretty flat, some hills here and there, not a whole lot of forests. And you also have the Gulf of Mexico that's nearby, and that's the moisture source. And with those southwesterly winds, southerly winds, you get the moisture from the Gulf of Mexico coming over this frying pan, and you get that convective storm action that we discussed earlier.
So tornadoes form over land. If we move on to hurricanes, they actually form over oceans. Why do
Yes.
they need the oceans in order to form the tropical system?
Well, it's interesting because if you think about it, if you compare tornadoes and hurricanes, the recipes for them are fairly similar. You're going to need a heat source, you're going to need a moisture source. However, with hurricanes in the tropical oceans provide the heat source and an endless supply of moisture. That water vapor is going to rise and form thunderstorms and ultimately hurricanes based on those same kinds of things that are going on over land with tornadoes.
We live in the United States, so we're used to the systems that we see here. We call hurricanes hurricanes, but they have different names depending on where they developed across the globe, correct?
Yes.
So what's the difference between a hurricane, a cyclone, and a typhoon?
Nothing. Actually, the technical term for all of these things, all of these phenomenon that everybody has different names for, is tropical cyclone. So if you're talking to a nerdy scientist like myself, we might say tropical cyclone. Yeah. But in different regions, they call them different things. So here in North America, in the North Atlantic, we talk more about hurricanes than we do about typhoons because that's just what we call them. Around China, Taiwan, Japan, that's the typhoon zone. But it's basically the same thing. The storms form the same way. It's just what they call them. And then typically everywhere else, it's a matter of kind of a mix between typhoon and cyclone, pretty much more cyclone than anything else because that's just what they call them.
Got it. So they all start the same way. They're just a tropical depression, and it really depends on if it intensifies enough and becomes a storm, and then if it strengthens all the way to what we refer to it as a Category 1 hurricane. The name can just change depending on where this formation happens around the globe.
Mm-hmm. Yes. Everybody's got different names for things. In the common parlance between these different regions, they call them cyclones.
So John, Hollywood loves a good disaster movie. Oftentimes these disaster movies are rooted in some type of weather event. And in the movie, they depict the meteorologist or the storm chasers as action heroes. They are exaggerated a lot of the time for entertainment value, but there is some truth to what these experts have to do in order to get the data to best predict these systems and hopefully protect us as best they can. Do you think that we'll ever get to a point with that technology will be so advanced that we don't have to send people into the eye of a storm?
What we need to do is we need to take measurements in order to get a sense of the storm. And some of those measurements you can get from space using satellites, get a sense of the size of the storm, the heat level of the storm, the infrared that's coming off of the storm, those kinds of things. But you're still going to need something to go through the cross section to see how high the winds are, to gather pressure readings, etc. So that's why we use those Hurricane Hunter aircraft to go through. Now, are we going to ever get to a point where the satellites will be so sophisticated that they can just take a snapshot of a developing storm and go, okay, this is how strong the hurricane is going to be in a week and this is where it's going to go? Maybe, but it's pretty speculative right now. It's kind of a combination of remote sensing from satellites, but also ground truth or close to ground truth measurements through Hurricane Hunter aircraft and the measurements that those take.
John, thanks again for joining us. I'm sure we'll talk again in the next couple of months. It's been a very eventful 2020, but hopefully the hurricane season is not too intense this year.
Matt, thanks for having me on. I share your sympathies. Let's hope we catch a break this year.
All right. Thanks, John.
You're welcome.